Hello. And so this year, our electrical VI team was tasked with, our VI team consists of Eugen, Alex, Udima, James, and I. And we were tasked with organizing the communication between the computer and the peripherals, regulating the power between and the signals between the teensy sensors and thrusters, and shifting logic levels between 3.3 volts and 5 volts. And as well, we wanted it to be really easy to connect sensors and speed controllers. And we could have done all these things with a big mess of wires and connectors, but we wanted to be sophisticated and engineer stuff. So instead, we designed and manufactured a circuit board to do all of those things. And this involved the team breaking up all the circuits into parts and drawing the electronic schematics, creating a computer model of the board in Altium, which Eugen will talk about in a second, and then making several iterations to perfect the motherboard through design reviews with Seth and the rest of the team. And we also selected and ordered components so that we can test the board and then solder the final design.
As you can see, our current board layout in 2D is shown on the right, and the digital isolation line is seen in the middle of the board, and this just isolates the connections between the computer and the thrusters. And we decided to use opto-isolators in particular because it eliminates potential noise from ground loops between analog and digital signals. So the current design of the motherboard has currently 5 main subcircuits. So the first subcircuit is just to monitor the battery voltage, and this is using a combination of a voltage divider and an analog to digital converter. We also have a circuit for an I2C level shifter, and this is to provide different I2C ports that operate at different voltages to the computer and thrusters. We have circuits for the kill switch and also the start switch. And lastly, our last subcircuit is for the PWM isolation. We use a digital isolator to prevent potential noise coming from the thrusters that could maybe interfere with the signals. And a schematic example of one of the subcircuits is seen on the bottom, and this is just the circuit connection of the I2C header pins.
So after designing the circuit board this semester, the PCB has been ordered and is currently in manufacturing. Once it's fully processed and assembled, we will be thoroughly testing for proper inputs and outputs with pass-fail criteria and to check if it completely works within the full electrical system. The board will then be redesigned for any errors and finalized by mid-June. You can see the board over off on the right-hand side that's currently being ordered and manufactured.